Hello, welcome to this video mini lesson introduction to chi-square and contingency table analysis. The beautiful thing about chi-square is it's so incredibly versatile. You can use it with just about any kind of data, including skewed data and nominal data. Now, up to this point, most of the types of statistical analyses that we've studied have required interval level data and normally distributed data, but neither of those requirements holds true for chi-square. Chi-square works by using frequency counts. For example, this data comes from a study by Ingersoll and Orr in 1989. And as you can see here, they looked at whether dropout risk differed by gender for male and females, and also by whether or not students had ever run away before. And what you're seeing here, these are actual numbers of students, cases of students, the frequency counts that fall into each of these different categories. And then what Ingersoll and Orr did is they used chi-square analysis in order to determine whether the differences between males and females as far as risk for dropping out was statistically significantly different. Down here, they did the same thing to determine whether the difference for runaways as far as dropout risk was statistically significantly different. So that's how chi-square works. It works with frequency counts, actual number of cases that fall into the different categories. And what you're seeing here are actually contingency tables. And when you do an analysis based on contingency tables, it's referred to as cross-tabulation or crosstabs. Now, there are a number of uses for chi-square. First of all, you can do what's called goodness of fit. That's when you have one variable with multiple categories. And let me show you an example of that. Where did that go? Here we have fifth graders' choice book genre. So when fifth graders get to choose their own book for independent reading, we might be interested in seeing what kind of genres they tend to choose. So I could put the number of students in each of these categories who selected each of these different types of genres and then total them all up. This would be what's called a one-way chi-square, or because it uses one variable, the variable being choice book genre. Now, let's say, for example, that instead of just looking at genre by students, I wanted to actually break students down into male and female. So all of these totals here for each of the genres, I would then break into two different categories, one for females and one for males. That would be what's called a test of independence, when I'm using more than one variable. That's also known as a two-way chi-square. So if I were, in this case, there would be two variables. One would be book genre, and the other would be gender. I would break this down into males and females, and we'll see an example of this in one of the other video mini lessons. Also, you can use chi-square for hypothesis testing, both for post facto and experimental designs, which is really nice. Now, the null hypothesis is simply that the expected frequency, or the expected counts, is equal to the observed counts, or the actual counts. So in other words, in our example here, I would look at what I would expect to see in each of these categories and compare that to what I actually see, my observed or actual frequency counts in each of these categories. And I'll talk to you a little bit more about how we figure out what the expected frequencies are. We'll talk about that in another video. And then the alternate hypothesis here is simply that the frequency that's expected is not equal to the actual or observed frequency. Now, when you're using chi-square for experimental designs, you're going to be using a pre-post type of situation probably, or different points in time, like point 1 in time, point 2 in time, etc. So in those situations, you're going to be dealing with the same participants in your research at different points in time. And if you recall, anytime you're doing that, you have to use what's called repeated measures, because your participants, your cases are going to be structurally linked, because it's going to be the same people. That's why they're structurally linked. Anytime you're doing pre and post or different points in time like that, which might be fall of 2012, spring of 2013, fall of 2013, something like that. Now, when you're doing repeated measures with chi-square, you can use McNamara's test It's a form of repeated measures chi-square analysis, and we might touch on this briefly in class. What's also nice about chi-square is it can be used for parametric or non-parametric analysis. So parametric, if you recall, is where you're looking at a specific sample and seeing if it's part of a particular population. So you can do a parametric analysis with chi-square. You can also do a non-parametric analysis. Instead of looking at whether a sample is part of a population, you're looking at whether actual observed frequencies are consistent with expected frequencies. This is your brief introduction to chi-square and contingency table analysis. Please now view the video for goodness of fit. Thank you.